Hey there, Grant here for the Flame Learning channel. In part 3 of Maya for Flame Artists, we went through some of the suggested workflows in Maya 2017 to optimize the geometry for the Action 3D compositor. This included improved structuring of the 3D scene for the Action schematic, as well as reducing the poly count and consolidating the 3D geometry to increase the Flame interactive performance and rendering. In part 4, we'll go through the process and settings for the FBX export, as well as compare the optimized FBX against the original version. If you would like to follow along, please go to part 1 to get the link to download the media. So picking up from part 3, we have an optimized 3D scene, and we have already saved a copy of the Maya scene as a backup. Now to export an FBX, you have two choices. Click the File pull-down menu. You can export a selection or everything. Choose to export all. In the export window, ensure the file type is set to FBX. Next, navigate to your designated directory for export. Call the file Robot Battles for Flame.fbx. Let's quickly run through the format options. Under the Presets header, set the pull-down menu to Autodesk Media and Entertainment. This will reset all the export settings to this default setting. Now the various settings for the FBX cover a wide range of topics. This includes geometry, animation, cameras, lights, texture handling, and some other advanced options. In the geometry section, you shouldn't need to adjust anything, as these are correct for Flame. Under Animation, you can decide whether the animation is included as part of the FBX export. The remainder of the animation settings do not apply to Flame in this case. Under Cameras, you only get one option to include cameras or not. The same goes for lights. For embedding media, please enable this to ensure that any textures used will be saved inside the FBX file. It is also imperative that the image file formats are compatible with Flame so that they can be correctly read in Batch and Action. Finally, under the Advanced options, the scale factor for the geometry is automatic. You can also adjust this setting on Import in Flame. The axis conversion must be set to Y for the up axis, and this ensures your geometry is the right way up in Action. The UI is General Settings, and finally, the FBX file format allows you to choose the exported version of the FBX. I'd like to mention at this point that currently Arnold lighting and shaders are not embedded in the FBX. Therefore, they will be converted on export and appear different in Flame. Click Export All. The export takes place, and you might get the error window appearing. Here you will get warnings and their descriptions. When you click on a warning, it will tell you what happened during the export. For example, this one tells you that no textures were embedded for the particular lights. This doesn't really affect Flame, so it's not a major concern. Click Close and save the Maya scene. So that's our FBX exported out of Maya 2017. Let's return to Flame and see what you get. Returning to Batch, we have the first action node that contains the original non-optimized FBX that was imported in part 1 of the series. Go to the Batch node bin and drag out another action node. Double-click on this node and switch to the result view with F4. In the action node bin, double-click on the import node. Ensure the file type is set to FBX and enable the AutoFit option. Keep the import type set to Action Objects so that Action creates its own local copies of the geometries. Navigate to the new FBX file. Select the file and load it into Action. Before we examine the Action schematic, go to the Action Node Preferences. Under the Rendering tab, enable the Shading Settings and disable Ambient Lighting. You're now using the imported lighting from the FBX file. We'll also quickly scale the large axis objects in the viewport. Switch to the Preferences tab and decrease the scale to taste. Next, let's switch to the FBX camera. Exit the Preferences and switch to the Object menu. Go to the Default Cam tab and switch the result camera from Actions Default Cam to Camera 2. Scrubbing the time bar, you can see that we have all the same 3D geometry, textures, and animation from Maya. You would have gotten the exact same visual result importing the original FBX. However, looking at the action schematic using the tilde keyboard shortcut, you will see there are fewer nodes to deal with, and everything is more structured. You can press Alt-T to tidy up the schematic further. Regardless which way you look at it, the action schematic matches what you did in the Maya outliner. Firstly, you have the robot group, which comprises of 4 geometry objects that were combined and consolidated in Maya. There is the head, the body, the left arm, and the right arm. The head and the body also used multiple textures, and each texture is still accessible in the schematic. You can edit any texture property, as well as assign new materials using standard textures or PBR textures in action. We kept the left and the right arms separate, and their respective axis nodes contain keyframed animation. The Robot Battles 3D text is a separate entity as set out in the Maya outliner. And finally, here is our group of 3 lights, which also uses the same Maya naming conventions. Now, to illustrate that all the optimizations have been applied, let's compare the original imported 3D scene to this one. Go to a 3-up view using Alt-3. 1 large viewport at the top and 2 split down below. Assign the top viewport as the action schematic, the bottom left viewport as the result view, and the bottom right viewport as the batch flow graph. Select the top viewport and press Space A to frame the nodes to the view. This is the schematic for the optimized FBX import. Neat, clear, and structured. Select the first action node and frame all the nodes into the viewport. This is the original FBX import. I'd like to point out that the nodes are quite scattered. And if you look at the robot head, for example, it is made up of so many objects, which could be one geometry with multiple shading groups instead. Flicking between the 2 action nodes, you can see the differences in the 3D scene structures. This will also impact on interactivity and render performances, so please give it a try and see for yourself. Now, before I conclude this video, I just want to mention that you can enhance this Maya to Flame interop workflow even further by using the Read File import type within the Action Import menu. This allows you to have a live link to the imported FBX or Alembic file, and any updates you make to the file externally will update in Action. If this is something that interests you, please refer to the video on importing 3D geometry in Action. That video covers all the import settings, as well as other issues like dealing with transparencies and more. I hope the Maya for Flame Artists series has been useful, and good luck with optimizing your 3D scenes for Flame. Comments, feedback, and suggestions are always welcome and appreciated. Thank you for watching, and please subscribe to the Flame Learning channel for future videos.